For our final video of the school year, we are going to take a look at transformations with our trig functions. So this is our general form. When I say trig here, I mean sine, cosine, tangent. Those are the three we're going to look at, but later the same transformations will work for cosecant, secant, and cotangent. And we're going to look at what happens when you change a, b, h, and k. So we're just formalizing what we had done previously in the explorations. Before we do anything else, we're going to take a look at our three parent functions. So again, we're going to concentrate on sine, cosine, and tangent, and then this can be expanded to our other reciprocal ones. So I'm going to start with sine, and I'm going to start with our table of values. So sine, remember, starts at 0. Now I'm looking at the quadrantal angles. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And I'm looking at those because they're the easy ones. They're going to be 0, 1, or negative 1. So sine starts at 0, goes to 1, goes back to 0, goes to negative 1, goes back to 0. So if I were to graph it here, I would go 0, and then pi over 2, and then 0, and then, so it looks like this. So that's one cycle or one period. Now, I can go backwards as well. I'm just going to continue that. So it's going to go negative 1, 0, 1, 0. So that shows me two complete periods there. And then that just continues over and over and over again. This table of values is important to us. Remember that sine starts at 0. Now, the key features are amplitude is equal to 1. The period, we had looked at it before in degrees. Same thing, except we're going to do it in radians this time. So it completes in 360 degrees or 2 pi. My midline is y equals 0. The x-axis is my midline. What am I missing? I've got amplitude, I've got period, I've got midline, and that's it, right? Okay, I feel like I'm missing one of my key features. Oh, domain, all real numbers range from negative 1 to 1. We might as well write it. Domain is all real numbers, and range goes from negative 1 to 1. Okay, so that's sine. Cosine is going to be very similar, except instead of starting at 0, we're going to start at 1. So cosine, and again, my table of values here, I'm using my quadrantal angles because they're easy. So I'm going to start at 1, go to 0, go to negative 1, go back to 0, go back to 1. So at 0, I'm at 1, and then 0, and then negative 1, and then 0, and then 1. So that's one complete period there. And again, I can go backwards. 0, negative 1, 0, 1. And yeah, that's going to loop back down now. All right, and so my amplitude again is 1. My period is 2 pi. Again, when we were doing the exploration, we did everything in degrees. All I've done is convert it over to radians. The midline is y equals 0. The domain is all real numbers. And the range goes from negative 1 to 1. I know I'm a little messy here, but that's okay. All right, and then our third and final parent function we're going to look at today, in this course, is tangent. Secant, cosecant, and cotangent are actually quite interesting, but we're okay. We'll look at those in another class. So for tangent, I'm not looking at my quadrantals anymore because I want to look at one full period. So I'm starting at negative pi over 2, and it's going to be undefined there. So I'm just going to put a little slash. At negative pi over 4, it is going to be negative 1, and I'm just using my unit circle here. At 0, it's going to be 0. At pi over 4, it's going to be 1. And at pi over 2, it's going to be undefined. So I'm going to have an asymptote there. In fact, I'm going to have an asymptote every pi, every 180 degrees. Okay? And then what's going to happen, so this is going to be 0, this is going to be -1, this is going to be 1, and then I'm going to hug those asymptotes. That's going to happen at each of these. That's going to go down, and then 1, -1. And then halfway between the asymptotes is where it's going to be 0. And that would continue up there. Okay, now remember it's undefined at -pi over 2 and pi over 2 because tangent is sine over cosine, and cosine is 0 at those spots. So it would be over 0, which is what makes it undefined. You can't divide by 0. Tangent does not have an amplitude because it doesn't oscillate the same way. We don't really have a midline because you're not going from the max to the min dividing by 2 since there is no max or min. But the middle is that y equals 0. We just don't call it a midline. The period is pi. From -pi over 2 to pi over 2 is pi. You're going to have asymptotes at, so we did this, we defined this using degrees. Let's define it using radians now. You're going to have asymptotes at pi over 2, and then every multiple of pi added to that, where n is an integer. So pi over 2 plus pi, plus 2 pi, plus 3 pi, minus 2 pi, minus 3 pi. The domain is going to be all values for x, where x is not equal to pi over 2 plus pi n. N is an integer. And our range is all real numbers. So that's our 3 parent functions. Now what we're going to do is use these parent functions to help us graph. Now I'm going to kind of talk about these, and then so that our video doesn't get too long here, I'm going to look at some examples from the worksheet in the next video. So for sine and cosine, the A is going to be your amplitude. It's going to be your vertical dilation. That's the transformation. But key feature-wise, that A value is going to be your amplitude, remembering that amplitude is always positive. So if you get a -7, then your amplitude is 7, and there's a reflection. So just being careful there. You can get the new period for the transformed function by doing 2 pi over b. That's going to be a horizontal dilation. So that's going to be the squeezing or the pulling from left and right. Whereas amplitude is the squeezing and pulling from top and bottom. Your C is your phase shift. That's going to move you left or right. And your D is your vertical shift, which is going to move you up or down. That's also going to give you your midline. Okay. Now, again, for tangent, I don't have an amplitude. It's just not defined for tangent because it's not oscillating in the same way. To get to the new period, you're going to do pi over b. So it's pi instead of 2 pi because the normal period for sine and cosine, which when I say the normal period, I mean of the parent function, is 2 pi. For tangent, it's pi. So pi over b is going to give you the new period. C is, again, your phase shift. It's going to move you left or right. In tangent, what's going to be most obvious is the movement of the asymptotes. And then D is your vertical shift or your translation. Now, the way that we're going to work these, and again, we'll do it in the next video, we're going to start by taking care of A and B. So for A, you're going to multiply the range values to see how that affects your amplitude, your y values. So when I say range, I mean y. For b, you're actually going to divide because it works backwards. Remember, with a, if a is greater than 1, then it's a stretch. With b, if b is less than 1, then it's a stretch. So I'm going to be dividing by b instead of multiplying by b. And when I say domain, I mean your x values. Okay, for c, that's moving us left to right, so we're going to add that to our domain. It's what we normally have called h. I don't know why we switch it to c for trig functions, but we do. And then for d, you're going to add it to the range. That's what we normally have always called k. All right, so again, in the worksheet, we're going to do another video where we look at a couple of them because it's not super obvious what to do yet, relating them back to our parent functions.